Now let us start the next topic, which are trees. Okay, and here specifically we are going to study binary trees. So in this topic we are going to cover binary trees, and in binary trees we are going to cover traversal. Okay, that is, the traversals are of three types. One is Inorder Traversal, then second is Preorder, third is Post-order. Okay, and we are also going to study what are the types of binary trees. Okay, and these types contain strict binary trees, complete binary trees, and almost complete binary trees. Okay, and after this we'll start binary search trees, and we'll see different operations on binary search trees, which are include insertion, deletion, okay, and other benefits of binary trees. Okay, so we'll be moving ahead to these topics of binary trees, but initially we first need to know what are binary trees. Okay, so what are binary trees? As the name suggests, binary trees are the trees which are having two child. Okay, so bi means two. We are also having ternary trees. We can also we are having ternary trees. Okay, we are having quinary trees. Here we are going to study binary trees and so on. Okay, so when I am saying binary trees, that means these are the trees which are having two child. Every node in the tree is having two child. Here also, here every node in the tree is having three child, and here every node in the tree is having four child, and so on. So we can have multiple trees of multiple degrees. Okay, so in case of binary trees, as you can see, whenever we talk about the trees, then how the tree look like? Tree looks something like this. So this may be actually a Christmas tree. I'm not very good at drawing this. So trees look something like this. So right, so where this is the tree start from this direction, and it is having multiple branches like this, multiple branches like this, and multiple branches like this. Okay, so in the same way, in computer science also we are having trees, but in these trees, these are actually the logical trees, where we are having nodes, which I will be representing like this, and these nodes may be having children. So these are the children for this node. Okay, for this tree, this is the left child, this one is the left child, okay, and this one is the right child. Correct. So for example, we are having this tree. Right, so in this tree, if you see this tree, this is called as, the initial node is called as the root of the tree. Correct, and these are the childs. For this root node, this complete is the left subtree. This is called as the left subtree, and this complete is the right subtree. Okay, and because as you can see, this node is having two child, so for this node, this is the left child and this is the right child. Okay, now if we talk about this particular node, for this node, this is the left subtree and this is the right subtree, and here this is the left child and this is the right child. Okay, and if we talk about this node, for this node, this is the left subtree and this is the right subtree, right? That means for every node, we may be having a left subtree or we may be having a right subtree, and it is not necessary that every node is having a left child or a right child. It may happen that some nodes are not having the left child and some nodes are not having the right child. So the nodes which are not having any left child or the right child are called as the leaf nodes. Okay. For example, in this first example, these two are the leaf nodes. Okay, they are also the left child and the right child, but they are also the leaf node. So any node which is not having a left child and the right child, that is both the childs, are called as a leaf node. Okay, so here if you consider this node is not having any left child and the right child, therefore this is a leaf node. Okay, this node is also not having any left and right child. This node is also not having any left and right child. This node, and this node, all these nodes are not having any left and the right child. Therefore, these nodes are considered as called as the leaf nodes. Okay, and all the nodes which are having a left child or a right child or both of them are called as internal nodes. Okay, and here in this case, this is an internal node, 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 and this is also an internal node. Okay, although this is a root node, but we are having these categories. So if a node is not having a left and right child, then it is called as a leaf node, otherwise it is called as an internal node, right? And we are also having a root node. So root node is a node which is like this. This is the root of the complete tree. Okay, and for this root we may be having a left subtree and we may be having a right subtree. Okay, now these trees can be categorized into different categories in case of their structure. Okay, for example, we may be having a strict tree, strict binary tree. Okay, we may be having a almost complete binary tree. Okay, and we may be having a complete binary tree. Okay, now let us see what are all these binary trees. Okay, so the strict binary trees are the trees where each and every node which is having a child is having either both the left and the right child. Either it is any node is not having any child, or if a node is having a child, then it will be having both left and the right child. Okay, and complete binary trees are the binary trees where all the nodes are completely filled to the same level, right? And almost complete binary trees are trees where nodes are added by the level order. Okay, let us see what are these. For example, if we are having this tree. Okay, now in this tree, this is the root node, this is the left child, and this is the right child. Okay, so this tree is also a strict binary tree. Why? Because every node which is having a child is also having a left child and a right child. Okay, so this is almost complete binary tree. So you will see what is almost complete binary tree in a moment, and this is also a complete binary tree. Okay, right? Now if I say I am having a tree like this, which is having these many nodes. Okay, now in this tree is a strict binary tree. Why? Because all the nodes which are having a child, then that node will be having a left child and a right child. Right? Here also this node is having child, so that it will be having a left child and a right child. This node is having a child, it will be having a left child and a right child. Okay, and it is a almost complete binary tree. Why? Because whenever we fill the nodes, then we fill the nodes in a level order. That means from this direction, let me just draw the direction. If we are going to fill the node, then initially we are going to fill this node, then we are going to fill the node in this direction, and then we are going to fill this node in this direction. Okay, here in the previous diagram also, if we are going to fill the nodes, then the nodes will be filled in this direction. Okay, now this is not a complete binary tree because every node the tree is not completely filled up to the same level. Okay, so now let us see what are levels and what are complete binary trees. Now for example, if we are having this tree, okay, now in this tree, this is one level, this is other level, and this is other level. So these are called as the levels in a tree. So in a complete binary tree, all the nodes which are the leaf nodes, all the leaf nodes are the same level. Now let me just write the definition. Strict binary trees are the binary trees if a node is having a child is an internal node, that means it will be an internal node, then it will be having both the left child and the right child. Okay, and in case of complete binary tree, all the leaf nodes will be at same level. Okay, for example, this is a level, right? So this is a level, this is a level, and this is a level. In this tree, all the leaf nodes are at the same level. But in this previous case, all the leaf nodes are not at the same level. Why? Because the level of these nodes are different and the level of this single node is different, right? And here in this case, all the leaf nodes are at the same level. Correct? Now this last example which we took, this is also strict binary tree. Why? Because every node which is having a child is having a left child and a right child. This node is having a child, it is having a left child and a right child. This node is having a child, this is having a left child and a right child. Therefore, this is also a strict binary tree. This is also almost complete binary tree. Why? Because if we fill the levels, then the leaves, these nodes are filled in this level, in this case, like this. Okay, and this is also a complete binary tree. Okay, now let us see an example. Now if for example we are having this binary tree, right? Here in this binary tree is a strict binary tree. Why? If a node is having a child, then it is having both left child and the right child. If a node is having a child, it is having both left child and the right child. Okay, and this is not a almost complete binary tree. Why? Because if we start filling the nodes, then this will come to this direction, this will be filled first, then this will be filled first, the nodes should be filled here, right? That means we are not having these nodes. Okay, we are not having these nodes. Because we are not having these nodes, therefore this is not a almost complete binary tree, right? So in case of almost complete binary trees, the nodes are filled level by level in this direction. Okay, and right, and is this a complete binary tree? No, this is not a complete binary tree. Why? Because this node and these nodes are not at the same level. So all the leaf nodes should be at the same level in case of complete binary tree. So this is only a strict binary tree. Okay. Now let us suppose we are having this example. Right. So in this example, if you see, then is this a strict binary tree? No, this is not a strict binary tree. Why? Because every node which is having a child, then it will be having both left and right child. For this node, it is having both left and right child, but this node is having only a left child, this node is not having any right child. Therefore, this is not a strict binary tree. Okay. Then is this a almost complete binary tree? Yes, this is an almost complete binary tree. Why? Because all the nodes are filled like this. So this is the root node, then these nodes are filled, then this node is filled, and then this node is filled. Okay, therefore this is a almost complete binary tree. Is this a complete binary tree? No, this is not a complete binary tree because all the leaf nodes are not at the same level. This node and this node, both the nodes are not at the same level. Okay, now let us take one more example. If we are having this tree, okay, so is this a strict binary tree? Yes, this is a strict binary tree. Why? Because every node which is having a child, it is having a left child and a right child. This node is having a child, it is having both left and the right child. This node is having a child, it is having both left and right child. This node is having a child, it is having both left and the right child. Okay, so is this a almost complete binary tree? No, this is not a almost complete binary tree. Why? Because if we start filling the nodes, then this will be filled first, then this will be filled first, then this will be filled first. After this, these nodes should be available. That means this node and this node, they should be available, but they're not available, they are missing. That is why this is not a almost complete binary tree. Okay, now is this a complete binary tree? No, this is not a complete binary tree. Why? Because these nodes, all these are the leaf nodes, and these leaf nodes are not at the same level. Okay, so therefore this is not a complete binary tree. So I guess you should know now, you should know after this that what is the difference between a strict binary tree, almost complete binary tree, and complete binary tree. Okay, in a lot of cases this strict binary tree is also called as full binary tree. Okay, and most of the students confuse this full binary tree with the complete binary tree. Okay, even though the name looks the same, complete and full name looks the same, but whenever I am talking about full binary tree, it means I am talking about the strict binary tree. Okay, and there's a difference between the full binary tree and the complete binary tree, right? Now let us see some more things about trees. Now for every tree there will be something called as the depth of the tree and something called as the height of the tree. Okay, and here this height and depth both are both we can talk about the tree, height of the tree, and even height of a node. Okay, now let us see what is the height and the depth of the node. So initially we are going to see what is the height. For example, we are having this tree. Okay, so what is the height of a node? So height of a node can be defined as the maximum distance from the leaf node. Okay, now here in this case the height of this node, because this node is a leaf node, the height of this node is 0 because this is itself is a leaf node. The height of this node is 0 because this is a leaf node, and there is no difference between this node and any other leaf node. Actually, okay, the height of this node is 0. The height of this node is 0. Okay, and then this is not a leaf node, so this node must be having some height. Okay, and the height is calculated as the maximum distance. So here the maximum distance is calculated as the number of edges between the leaf node. So here this maximum edge is 1, therefore the height of this node is 1. Okay, for this node, what is the height? For this node, if you go to the right direction there is only one edge, but if you go to the left direction there are two edges. That is, we have to take maximum of 2, 1, because in the right we are having one edge, in the left we are having two edges. So for this node the height is 2, because in 2 and 1 the maximum is 2, therefore this node the height is 2. Okay, now for this node what is the height? For this node the height is 3. Why? Because if you go in the right direction, this is the first edge, this is the second edge, and this is the third edge. Okay, so these three edges gives the maximum distance between the leaf node and this node. So therefore the height of this node is 3. Okay, now for this node, this is a root node. So what is the height for the root node? The height of this root node is 4. Okay, and this height of the root node is also called as the height of the tree. So whenever I am saying the height of the tree, that means I am talking about the height of the root node, and whenever I am saying height of a node, that means I am talking about the height of any particular node. Okay, this is how the height is calculated. That means for the leaf nodes the height is 0, right, and for the above nodes more than which are as far from the leaf node, the height is something else. Okay, now if I talk about the depth is calculated like this, right, from root node to the leaf node. How much is the depth? For the same tree, if I find out the depth, then you'll see the depth of the root node is 0, right, and the depth is a maximum distance from the root. So depth is max distance from root. Okay, so here the depth of this is 1, the depth of this is 1, the depth of this node is 2, the depth of this node is 2, and the depth of this node is 3, the depth of this node is 3, and the depth of this node is 4. Okay, so this is the difference between the height and the depth of a tree, right? Now let us suppose we are having these multiple trees. So this is the first tree, this is the second tree, this is the third tree, this is the fourth tree. Okay, let us suppose we are having these trees. Now tell me the heights of all these nodes, right? I am writing the names of these nodes. Till the time I write the names, please find the height of these nodes. Okay, now for this node the height is 0. For this node the height is 1. For this node the height is 0. And for this node the height is 2. For this node the height is 0, its height is 1, its height is 2, its height is 3, its height is 0, and for this node the height is 4. Okay, for this node the height is 0, its height is 1, its height is 0, its height is 1, the height of this node is 2, the height of this node is 3. Now for this node the height is 0, for this node the height is 1, for this node the height is 2, for this node the height is 3, for this node the height is 4, for this node the height is 0, and for this node the height is 5. Okay, and the height of this complete tree is 2, the height of this complete tree is 4, the height of this complete tree is 3, and the height of this complete tree is 5. Okay. Now, for example, if you are having they have given you a tree. So this is the tree A, B, C, D, E. Okay, and this is a tree A, B, C, D, and E. And this is some other tree A, B, C, D. Okay, so how I am representing every node with a circle. Okay, but what are these nodes actually? Okay, how can you program these nodes, and how can you write the programs to create binary trees? Okay, so if you see every node, the structure of a node is like this. So struct node, we are having struct node star left. Okay, then we are having, for example, character data. Then we are having struct node star right. Okay, this is the structure for a node. And then I am doing struct, so I should do type definition here actually. So I am doing type def struct node as node. Okay, so this is these are the trees which we are having, right? And how this tree is actually stored, how this tree is actually represented, it means there is a root node. So this is the root node which is storing some data which is A, and it is having a left pointer, a data part, and a right pointer. Okay, then there is a node which is B. Okay, this B is having a left pointer, a right pointer, and a data part. There is a node which is storing C. Okay, this is the left pointer, this is the data, and this is the right pointer. Okay, and there is a node which is storing D, and there is a node which is storing E. Okay, and this is the left pointer, this is the right pointer, this is the left pointer, and this is the right pointer. Okay, now let us suppose all these nodes are having some addresses in the memory. For this node the address is 1000, for this node the address is 2000, for this node the address is 3000, and for this node the address is 4000, and for this node the address is 5000. So this left pointer is pointing to this node, so this will be storing 2000 here, and this is right pointer is pointing to this node, therefore this will be storing 3000 here. Okay, for this left pointer is actually pointing to this node, so it will be storing 4000. This right pointer is pointing to this node, therefore it will be storing 5000. And these nodes are not pointing anywhere, therefore it will be storing null here. Null, 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 and null. Okay, this is how you can view a node of a tree. So instead of showing all these things which actually denote a node by this circle. Okay, so whenever I am writing a circle, that means we are having the nodes like this. Okay, and this is actually pointed by a pointer which is called as a root, right? That means there is a pointer root which is storing 1000 in it. Okay, so for every node there will be something called as a root. Okay, now in most of the diagram I draw a binary tree like this, but in all these trees I should draw something like this also. The directions, it is important, but whenever I'm not drawing the directions, please assume the directions are like this. Okay, so these directions are showing which node is pointing to this which node, and in all these cases there will be a pointer root which will be pointing to a root node. There will be a pointer root which will be pointing to the root node. Okay, now the first thing is, for example, if you are having a tree, right, and you want to print all the data which are present in the tree, right, and the question is, how will you print the data which are present in the tree? Correct. So for this is called as a traversal. Traversal means we are going to print whatever the data which is present in a tree, and there are different kinds of traversal techniques. So first traversal technique will be inorder, which we are going to study. Second traversal technique will be preorder. The third traversal technique will be post order, and then we are going to see what are double order, and then we are going to see what are triple order. Okay, so in order, let us see what is this in order, pre-order and post order. So the first is in order traversal. Okay, so initially what I am going to do is I am going to write a program for in order and then pre-order and the post order. Then I am going to explain what is this traversal. Okay, so this is for in order, then we'll be doing pre-order traversal, or I should just write them here, and then we'll be doing post order traversal. Okay, and here is a space for the programs. Okay, so in the in order, the function will be like this: in order node star root. Okay, and it will also take pre-order node star root, and it will take post order. These are the function names actually. Node star root, that means all of them are going to take the pointer to the root. Okay, and then in the in order we are going to say if root. Okay, and if root is not null, then what we are going to do is we are going to call in order root left. It is a recursive call, and then we are going to print the data present in the root. So printf %c comma root arrow data, and then we are going to call another recursive call which will be in order root arrow right. Okay, so this is your in order, and then in the pre-order what we are going to do is if root, then printf %c comma root arrow data. Then we are going to do pre-order, that is, this will be a recursive call root arrow left, and then there will be one more recursive call which will be pre-order root arrow right. Okay, and in the post order we'll be having if root, then we are going to do post order. This will be recursive call root arrow left, then post order root arrow right, and then printf %c comma root arrow data. Okay, so this will be root arrow data. Okay, so this is the program for post order. Correct. So as you can see in all these programs, what is the difference? What is the difference which you can find in these programs? In all these programs, the printf statement in case of inorder is between the two recursive calls, right? Here the printf statement, as the name suggests, preorder. So the printf request will be at pre, that means before these two recursive calls, right? And here the printf request is post, that means after these two recursive call, and all these recursive calls are the same, that means they are calling the function itself. Okay, now this inorder shortcut way we can also call as inorder, as we are going to visit the left node, and then we are going to visit the root node here, and then we are going to visit the right node. Here also here we are going to visit the root node first, then we are going to print the left node, and then we are going to print the right node. Okay, and here we are going to print the left, the right, and then the root. Okay, so if you see, for example, we are having this tree. Okay, now in this tree we are having some data. Let us suppose the data is A, B, C, D, and E. So every node will be storing some addresses. For this node, let us suppose this is the root node. Okay, so for this node, let us suppose the address is 1000. For this node, the address is 2000. For this node, the address is 3000. For this node, the address is 4000. And for this node, the address is 5000. Okay, so its left pointer is storing the address 2000, its right pointer is storing the address 3000. Its left pointer is storing the address 4000, its right pointer is storing the address 5000. Its left and right pointer both are null. Here also the left and the right pointers both are null, because these are the leaf nodes. Okay, now let us suppose I've called this inorder function onto this. Okay, and as you know, whenever we are going to do recursive call, then all the recursive all the data which is present in the recursive calls are stored in the form of the stacks. Okay, so let me just number the lines. So here this is the line number 1, this is the line number 2, and this is the line number 3. Here also this is the line number 1, the line number 2, and the line number 3. This is the line number 1, line number 2, and the line number 3. Okay, and in the line number 1, if we call inorder on this, then that means initially I've called inorder on 1000. Okay, so when I've called inorder of 1000, in that case the line number this if root means this statement will be executed. Why? The root is not storing null, so whenever root is storing null, this if statement will not be executed. Whatever the data present in this if statement will not be executed. Okay, so here this root is not null, therefore initially we are going to execute the line number 1, and after we finish the line number 1, then only we are going to execute the line number 2 and line number 3. Okay, so I guess it will be difficult to understand this. There is very less space, so I'll do it with some other method, the recursive calls. So I'll do it something like this. Initially I've called inorder, okay, and I've called inorder 1000. Okay, so when I called inorder 1000, in that case it is going to execute the line number 1, so it is going to call inorder 2000. So after it find the value of inorder 2000, then only it is going to print this output. Okay, so when it called inorder 2000, in that case it is going to call inorder 4000. Why? Because when it called inorder 2000, in that case the line number 1 will be executed. After executing the line number 1, then only we are going to go to the next statement. So when I called inorder 4000, in that case inorder 4000, right, so it is initially going to execute the line number 1, and the line number 1 it is going to call inorder of null. Why? Because if you see the node number 4, in that case its left pointer and right pointers both are not pointing to any other node, that is why it is a leaf node. Okay, so if you call in order of its left pointer, then this left pointer is null, right? So it is going to call inorder null, but when it called inorder null, nothing will be printed. Why? Because this if statement will be failed, so the control will go back to the previous statement. So then this inorder 4000 is going to execute its second statement, and second statement is printing the data which is present at the location 4000. Therefore it is initially going to print D. So output will be, for this, will be initially going to print D. Okay, and then it is going to call its third recursive call, which is Inorder null, right? Therefore this will not be executed. Why? Because the statement will be failed. So control will go back to the previous statement after this. So in the previous statement we have executed the line number 1. Now it is a turn to execute the line number 2. So in the line number 2 we are printing the data which is present at the location 2000. Okay, so what is the data present at the location 2000? It is B, therefore it is now going to print B, and then it is going to call Inorder 5000, that is which is the right subtree. So when we called Inorder 5000, in that case it is not going to execute the line number 1, because in the line number 1 this function call will be Inorder null. So when Inorder null, in that case this if statement will be failed, therefore control will go back to the previous statement, and then it is going to execute the line number 2. The line number 2 is a printf statement. So printf the data which is present at the 5000 location. So this is going to print E, and then we are going to call the this line number 3, so which is going to call Inorder null, right? Because its right child is also null, therefore this statement will not be executed. So control will go back to the previous statement here, because this Inorder 2000 has executed all its 3 statements. Okay, now we are going to execute the second statement for this 1000. So second statement is print the data which is present at the location 1000, therefore it is going to print A. Okay, and then it is going to execute third statement. Third statement is Inorder 3000, right? So Inorder 3000 means we are going to execute this statement, and its first statement will be Inorder null, because at the 3000 location the left pointer is null. So this statement will not be executed. Then we are going to print what is the data present at 3000 location. The data present is C, therefore it is going to print C, and then we are going to call Inorder null. So this will not be executed again. So control will go back to the previous statement, and this previous statement has executed all its 3 statements. So program will finish. The function will finish. So the function is going to print DBEAC. Okay, but this complete is actually a very lengthy process, right? So what we are going to do is we are going to just see whenever we are going to call, that means it is going to call left, root and right. That means the shortcut form is whenever you see the root, just visit the left root in Inorder, then visit the left root in Inorder, then visit the left root in Inorder. So whenever there is no leaf child, there is no left root, left node, then we are going to visit the root node, and then we are going to visit the right node. Okay, now for example, for this same tree, what we are going to do is we are going to visit, if you see the same child and we want to if you see the same tree and we want to visit the same tree in Inorder. Okay, so what we are going to do is see the root, then in the root left, root and right. So what we are going to say is visit the left root in Inorder. So now this is a new root for this node. What we are going to see, visit the left root in Inorder. For this node there is no left and right child. So what we are going to do is we are going to print the data. Therefore we are going to print D, and then we are going to visit the right child in Inorder, but there is no right child here. Therefore control will go back to the previous statement. Now we are going to say print the root, which is B, and then we are going to visit the right node in Inorder. So in the right node we are only having one node, so it is going to print it, and then control will go back to the previous statement, and then this will be visit the root and then visit the right node in Inorder. So if you see, this will print A and then this will print C. Okay, so this is how you can print the data in Inorder. Now let us see how to print the data in preorder. So now let us suppose we are having the same tree and now we are calling preorder. So what we are going to call is preorder 1000. So when we called preorder 1000, in that case the if statement is true because the root is not null, then we are going to execute the line number 1. In the line number 1, what we are doing is we are printing the data which is present at the root. Therefore it is going to print the data which is A, which is present at the root. Okay, and after that it is going to execute the line number 2, and the line number 2 we are going to call preorder the left child for this. Then the left child is having the address which is 2000, so it is going to call preorder 2000, right? So after this we have to find what is preorder 2000. So when we called preorder 2000, right, so in this case what it is going to do is it is going to execute the line number 1, and the line number 1 is saying print the data which is present at the location 2000, therefore it is going to print B. Okay, and then it is going to execute the line number 2, and the line number 2 will be saying preorder 4000. Okay, so when we call preorder 4000, in that case this line number 1 will be executed. So it is going to print what is the data presented at the 4000 location, which is D, and then it is going to execute the line number 2. In the line number 2, it is going to call preorder null. So when it called preorder null, nothing will be executed, because this if statement will be false. This the if statement will be false, and then we are going to call preorder the right child, which is also null. So this statement will be false, so control will go back to the previous statement, and in this previous function call, we have executed the line number 1, line number 2. Now it is a turn to execute the line number 3, right? Then in the line number 3, we are going to call preorder 5000. So when we call preorder 5000, in that case it is going to execute the line number 1, and the line number 1 is E, so it is going to print E. And then we are going to execute the line number 2, and the line number 2 will be preorder null, and this will not be executed, and the line number 3 will be preorder null. Okay, and then the control will go back to the previous statement after this, and the previous statement has executed all its 3 statements, therefore control will go back to the previous statement again, and it is going to execute the third statement, and the third statement will be preorder 3000. So when it called preorder 3000, in that case what happens is it is going to print the line number 1, execute the line number 1, and the line number 1 is printing the data which is present at the location 3000, therefore it is going to print C, and then it is going to execute the line number 2, which will be preorder null. Okay, and then it is going to execute the line number 3, which is preorder null. So none of these statements will be executed. So if you see in preorder, the data printed is A, B, D, E, C. So in case of preorder, if you see, we are going to print root, left and right. That means initially we are going to print what is the data present the root, then we are going to visit the left subtree in preorder, and then again in this left subtree we are going to print the root, and then again we are going to print the left subtree in preorder, again we are going to print the root, and then again we are going to print the left subtree, but here the left subtree is null, so we are going to print the right subtree, so which is also null. So control will go back to this statement, and now it is going to execute the preorder right subtree. Again control will go back to this statement, and it is going to execute the preorder the right subtree. Okay, so this is how the preorder works. Now let us see the post order. Now let us see the post order traversal. So in this case it will initially call post order 1000, right? And in this post order 1000, it is initially going to execute the line number 1. So the line number 1 will be calling post order 2000. So when we call post order 2000, in this case it is initially going to execute the line number 1, which will be post order 4000. Again it is going to execute this line, so it is initially going to call post order null, because the right left subtree for this 4000 location is null, and then it is going to execute the line number 2, which will be post order null. Okay, and then it is going to execute the line number 3, which will be data present at the 4000 location, therefore it is now going to print D. Okay, and then the control will go back to the previous statement, so it is now going to call post order 5000. So when it called post order 5000, in that case what will happen is it is going to call post order null, which will not execute. Again it is going to call post order null, which is also not going to execute. Then it is going to call print the data which is present at the location 5000, therefore it is going to print A, right? And then it is going to execute its third statement, which will print the data which is present at the location 2000, therefore it is going to print B. Okay, and then control will go back to this statement, and it is going to execute the line number 2, which is post order 3000. So when it called post order 3000, it is in that case it is going to call post order null, then post order again null, because left the right child both are null, and then it is going to print the data which is present at the location 3000, therefore it is going to print C, and then control will go back to this previous function call, so it is going to execute the line number 3 in this case, and now in this case it is going to print the data which is present at the location 1000, therefore it is going to print A. So this is the post order traversal for the same tree. Okay, right? So as you can see, this is printing left, right, and then root, again left, right, and root, left, right, and root. Okay, now let us see few more examples for in order, pre-order, and post order traversals.